Good morning, ladies and gentlemen. How are you going? So today we're going to start a new topic. We're going to look at further differentiation and applications part 3. So we're going to build on our knowledge, our previous knowledge of derivatives, which are gradients of functions. So what are second derivatives? Well, if you think of first derivatives, it's you differentiate once, so that's first derivative. So then if you take that answer and differentiate again, you have just second derivative, taking the second derivative. What does that mean in terms of context? Well, if you started off with displacement, if you start off with x, your function is a displacement function, then if you differentiate once, you get the velocity, the rate of change of displacement with respect to time, which we use as v, right? So v is dx dt because x is my displacement. Another notation we might use is like f dash of t. So we use dash notation because the function f was our original function, or we use the dx dt notation. If we decide to differentiate velocity with respect to time, we get acceleration. So before, in our derivative context, we said, hey, to work out acceleration, we just differentiate velocity, and then we can easily get the acceleration, the rate of change of velocity over time. But if velocity is the rate of change of displacement and acceleration is the rate of change of velocity, so technically acceleration is the rate of change of the rate of change of displacement, which in this case is your second derivative because your rate of changing the rate of change. So in terms of notation, acceleration is dv dt because it's the rate of change of velocity with respect to time, but we said that velocity is the derivative of displacement with respect to time. So you differentiate that again. So this is a new notation. If we double derivative or second derivative, we go d squared x over dt squared because you're looking at the rate of change of the rate of change of displacement. Or more commonly we use f dash dash. So if first derivative is f dash of t, then second derivative is f dash dash of t. So we usually tend to use the dash dash notation more, but sometimes you'll see this squared notation, so d squared x over dt squared. So you're taking the double derivative of x with respect to time. So in terms of algebra wise, you differentiate once, that's your first derivative, you take that answer and you differentiate again, that becomes your second derivative. In terms of context, if your starting function is displacement, you differentiate once, gives you velocity. If you differentiate that again, that becomes acceleration. So acceleration is the second derivative of displacement. Also, down here, similarly, if we have a function, then the first derivative is the rate of change of y with respect to x, or the gradient. So the first derivative is the gradient of the function. The second derivative is the rate of change of the gradient. So it's a rate of change of gradient of your original function because your first derivative is gradient. And as you can see here in the pink box, we talked about notation already. So commonly we use the dash dash notation because if one dash is the first derivative, then two dash is the second derivative. In fact, you can have many more higher order derivatives as well with different meanings and interpretations. Sometimes you'll see textbooks use the squared notation, so d squared y over dx squared, or you just differentiate in once more your initial derivative.